So a quadratic inequality is an expression which involves x squared and an inequality sign. So the graph of a typical quadratic equation would look something like this. But when an inequality is involved, we need to identify the range of values of x. That is, whether the region below the x-axis is required or the region above the x-axis is required. And in order to solve a quadratic inequality, the first step would, would be to find the roots. And the second step would be to draw the parabola. Now, after some practice, you might not feel the need to draw a parabola, but it is always advisable to draw one. And in this case, you won't need to find the turning point as you did uh, in AdMath if you are a student of AdMath. You only need to find the roots and simply draw a parabola. And then the third step would be to identify whether the region above or below the x-axis is required. So if we have a less than sign or a less than equals to sign, the region below the x-axis is required. But if the quadratic inequality has a greater than sign or a greater than equals to sign, then the region above the x-axis is required. And then the fourth step and the fifth step are just an elaboration of the third. So the fourth step says if the region below the x-axis is required, the inequality would look something like this, as I just explained. So in this case, the, we need to identify the region. So the first step would be to draw the, the parabola, and we'll do so. And then notice that the region below the x-axis is required. That is, the inequality states that x lies between a and b. So we'll shade this region. And now in the fifth step, if the region above the x-axis is required, that is, there is a the re, the inequality sign is greater than or greater than equals to, then the inequality would look something like this. And to represent such an inequality, we'll draw a parabola first, which passes through the roots, and we'll shade the region above the x-axis. That is this region and this region. And appreciate the fact that this is in line with a given inequality. That is, x is less than a, so x is less than a, and x is greater than b, so x is greater than b. And the graph would look the same for either of these inequalities. But if the question has an inequality such that the quadratic part of the inequality is of a maximum curve, then take the negative sign common, and whenever you mess with a negative sign, that is, you either take it common on both sides and then cancel it out, or you multiply both sides by -1. Then the sign of the inequality also changes, but appreciate the fact that doing so will convert it to a minimum curve. So in this chapter, whenever we have a maximum curve, always take the negative sign common. Doing so would change the sign of the inequality and would also convert it to a minimum. So now let's take a few examples. So our first example is 2x squared minus 9x plus 10 is greater than 0. So the first step is finding the roots. So we'll break the middle term as minus 4x and minus 5x. Then we'll take 2x common. This will leave x minus 2. And we'll also take minus 5 common. This would also leave x minus 2. So we have two factors, that is x minus 2 and 2x minus 5. And our two roots turn out to be x is equals to 5 over 2 and x is equals to 2. So now, since we have our two roots, we'll draw a graph of the inequality, which would look something like this. Just a second. We have 2 and 2.5. We'll draw a simple quadratic graph at first. Now notice the fact that we have a greater than sign here. This means that the region above the x-axis is required. So we'll simply shade this region. And now it's time for our final answer. So we have x is less than 2. So we'll write this. X is less than 2. And we have that x is greater than 2.5. So we'll write x is greater than 2.5. And appreciate the fact that if this sign was greater than equals to, then we'd also have equals to here. So this is our final answer. Now for example 2, we have 3x squared plus 11x plus 6 is less than 0. So we'll find the roots first by breaking the middle term. Take 3x common. And the factors turn out to be 3x plus 2 and x plus 3 is less than 0. And the two roots turn out to be minus 2 over 3 and x is equals to minus 3. And then we have to draw the inequality, which would look something like this. So we have minus 2 over 3, which would be somewhere here, and minus 3. The quadratic graph would look something like this. We need the region below the x-axis since it is a less than sign. So we shade this region. So the region required is between minus 3 and minus 2 over 3. So the inequality would look something like this. The smaller number comes on the left and the bigger number comes on the right. So x lies between minus 3 and minus 2 over 3. Or you can also read it as two separate parts. That is x is greater than minus 3 and x is less than minus 2 over 3. And this makes sense if you think about it. So our third example is this. We'll use the same technique, find the middle term first. No, find the roots by breaking the middle term. The factors would turn out to be, just a second. So the factors are 4x plus 3 and x minus 2. And the roots are x is minus 3 over 4 and x is equals to 2. The graph would look something like this. We had this, and this minus 3 over 4 would be somewhere here, and 2 would be somewhere here on the positive side. So our quadratic graph would look something like this. And the region we need is above the x-axis, since it is a greater than equal to sign. So this is the region we require, and we'll shade this. So the inequality for the first part would be x is less than minus 3 over 4. And for the second part would be x is greater than 2. And since we have an equal to thing here, we have a greater than equal to in the question, we'll also have an equal to in the question. So just put a line underneath. And yeah, that's our answer. Now our fourth example is our second last example. So we'll find the roots again, and we'll take 3x common, x minus 2, and minus 4 common 2, and x. The factors turn out to be 3x minus 4 and x minus 2, and the roots turn out to be 4 over 3 and x is equals to 2. So the graph, just a second, the, se the second step would be to draw the graph, and it would look something like this. And the region we require would be below the x-axis, since this is an this is a less than equals to sign. So we'll shade this region, and we'll write this inequality as x lies between 2 and 4, 4 over 3 and 2. So since we have an equals to sign here, we'll also have equals to here. So this is our final inequality. But just don't forget to put the equals to sign. So our last example, let's take this to be x square minus 5x plus 6 and greater than equals to 0. This example is important since we have a maximum curve, and we learned that whenever we have minus sign, it's a maximum curve, and in this case we'll take the minus sign common, or we can even multiply both sides by minus 1. The latter method is easier to convert this into a minimum curve. This would also change the sign of the inequality. So how about we multiply both sides by minus 1? So the sign of the inequality changes, and the expression looks something like 0 multiplied by minus 1 is 0. So now we'll find the roots as usual. So we'll break the middle term like this. We'll take x common to leave x plus 6 and minus 1 common to leave x plus 6. The two factors turn out to be x minus 1 and x plus 6, and the roots turn out to be x is equals to 1 and x is equals to minus 6. So the graph would look something like this. So we have 1 here and minus 6 here. We converted a maximum curve to a minimum curve. And now identify the region required. This is greater than equals to sign. So we require the region. No, wait. This is a common mistake. We change the sign to a less than equals to sign when we converted this to a minimum. So we'll take this sign into consideration. This is a very common mistake. So we now, after converting this to a minimum curve, we require the region below the x-axis. So shade this region, and the final inequality would be that x lies between minus 6 and 1. And also don't forget this equals to, since we have an equals to here.